Hey guys, in this video we're going to continue with our trig ratios and that theme with the triangles and figuring out the different trig ratios, kind of take this to the next level, if you will, today. So in all of these problems, we're going to be given one trig ratio. In this particular case, we are given that the sine of some angle A is 7 over the square root of 65. We're also told that this angle is in quadrant 1, which will always be the case for this first set of questions. We'll add different quadrants in the next set, but we're not going to really worry about that for right now. But what we're asked to do is find the exact value of the secant of A in simplest radical form using a rational denominator. So we're given one trig ratio, and we're asked to find a different trig ratio. So the first thing that I want to do is make sure that we all know SOHCAHTOA. All right, and you may want to also even just take a second to write out all 6 of the trig ratios, because you're going to need to know all 6. So if you know that the sine is opposite over hypotenuse, you know that the cosine equals adjacent over hypotenuse, you know the tan equals opposite over adjacent, and we get all of that just from SOHCAHTOA. And then we know the inverses of these, which with sine we have cosecant, and that is hypotenuse over opposite. With cosine we got secant, and that's hypotenuse over adjacent. And with tangent we got cotangent, which is adjacent over opposite. So those are all 6 things that you should just be able to figure out on your own. All you need to know is SOHCAHTOA, and then you can get all 6 of these. But definitely have them written out there to help you with this. Okay, so with that laid out, the first thing we're actually going to do is draw a triangle, because in all the problems we had on the previous video, we had a triangle drawn for us, and it had this size labeled. We aren't given that for this, so the first thing I'm going to do is just draw a right triangle. And you can just draw the same right triangle every single time. So I'm just going to draw a right triangle, and I'm just going to call this triangle A down here, B here, and C here. And again, just draw the same exact triangle every time. It just makes things consistent and easy if you do this. All right, and then we're going to take the information that's given, which it tells us that the sine of this angle is 7 over radical 65. So if we look at the sine ratio, that's the opposite over hypotenuse. So it's telling us the opposite side of angle A is 7. So if we look opposite of A, we get 7, right? And the hypotenuse, which is the bottom, is radical 65. So I'm just going to label that radical 65, the hypotenuse there. Remember, the hypotenuse is always opposite of the right angle. So with that labeled, let's think about what the question asks us. The question asks us to find the secant of A. So the secant is hypotenuse over adjacent, right here, right? Well, we know the hypotenuse, but if we're looking at A, we don't know the adjacent side. So we got to figure out that adjacent side. What is this? The easiest way to do this is using something that you've learned, I don't know, several years ago, which you should know, and that is the Pythagorean theorem. Because the Pythagorean theorem, if we know any 2 sides of a right triangle, we can then find the third side. And hopefully you know that one, a squared plus b squared equals c squared. Just remember that the c is always the hypotenuse. So when we do this, we don't really know, you can just say a or b, it doesn't really matter. We'll just say a squared is what we don't know. So if we don't, a squared plus, now the other leg is 7 squared, equals our c, which is radical 65 squared. And I put that in parentheses because when we square that radical, it's just going to make it go away. So we're going to solve here, and we get a squared plus 49 equals 65. We then subtract the 49 over. We get 16. And then we take the square root. So a is 4. Technically it's plus and minus 4, but we're just talking about positive sides here. So we want the positive root, which is 4. All right, so we found our missing side of 4. Now we can answer the question of what is the secant of A. So the secant of A then, this is what we basically practiced from this step of the last video. We were just given all this information up to this step. So the secant is hypotenuse, which was radical 65, over the adjacent, which is 4. So radical 65 over 4. Now we do need to make sure that this is in simplest form. The radical is simplified. Another thing that I gave you in the last video, which you might want to write down if you didn't at that point, was this list of perfect squares. So like the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. It's just helpful to have all this written out so you don't have to think through it and miss one of them possibly. So this list here that I gave you, radical 64 is 8. And just, again, have all these known here. That should be good there. So when we're asked to simplify the radical, something that we've done quite a few times, we want to look for any of these perfect squares that are inside of it. So 64, nope. 49, nope. 36, nope. 25, nope. And none of these numbers, 9, no, 4, no, none of those numbers go into radical 65. So we can't simplify that at all. So this will be our final answer here. The square root of 65 over 4. I know it probably seems like that question took a really long time. They won't all take this long because we'll have all this information already written out for us. Okay, let's go ahead and give another shot here. Next one. Let me delete the stuff that we don't need. All right. So keep all that other stuff that I have written there handy. Your table of radicals there, that's going to help us for simplifying, and then all of our trig ratios up here as well. All right, let's start by going ahead and drawing a triangle. Again, just draw the exact same triangle every time. So I'm just going to draw the same right triangle here. And go ahead and just label it A, B, C. So it gives us the cotangent of A. So from A, cotangent is the adjacent over the opposite. So the adjacent side is 2 to A. So that'd be here is 2. And the opposite of A would be over here, is 5. Adjacent over opposite, because that's cotangent. So we need to find the missing side over here, the hypotenuse. So using the Pythagorean theorem, it's just going to be 2 squared plus 5 squared equals c squared. All right, because we're given 2 legs, so we get 4 plus 25 equals c squared. So that's 29 equals c squared. Take the square root of that. So then c is just the square root of 29. That is actually simplest form. There's nothing else we can do there. So we're just going to go ahead and write that as the square root of 29. Okay, then let's think about what we're asked to find. We're asked to find the sine of A. The sine is the opposite over hypotenuse. So the opposite of A is 5. Already knew that one. And the hypotenuse was the square root of 29, which we found. So that is our answer, but we cannot leave it like that because that is not a rational denominator. So what we do, I will multiply by radical 29 over radical 29. On the top, we have 5 radical 29. On the bottom, we have 29. Seems like a bad answer, but that's what we want to type in because we can't reduce 5 29ths. That does not reduce. Square root of 29 does not reduce either. There's no perfect squares inside of that. So we do actually want to just type in 5 radical 29 over 29. As our final answer. All right, let's try one more and then we'll add some different quadrants to it. So all of these are going to start the same way again. Start by just drawing your triangle, identify the information that's given to you, and label it accordingly. A, B, C. It is a good idea to make sure you're labeling your right angle down there always as well. Okay, this gives us the cosecant of A. So we find our cosecant, which is here. Cosecant is hypotenuse over opposite. So that's saying the hypotenuse should be the square root of 85. And the opposite of A should be 2. So we need to find this one down here. So we'll just call that our a. So a squared plus 2 squared equals the square root of 85 squared. So then we get a squared plus 4 equals 85. We then subtract the 4. So a squared is 81. And take the square root of that. We do get a nice perfect square of 9. That's good. So it goes down there. So now we can find what we're asked here. We're asked to find the cotangent. Cotangent is adjacent over opposite. So cotangent of A. Adjacent of A is 9, the one we just found. And opposite is 2. So 9 over 2. No radicals to worry about on that one, so we can just go ahead and just make sure it's simplest form. It is. So we'll just go ahead and type in 9 over 2. All right. The next section, we're going to add just a bit to it. The only thing that's going to change in this section is the quadrant, possibly. This first one actually doesn't change, so I'm going to go to the next one. All right, so everything about these questions is exactly the same. The one difference being that sometimes it'll say quadrant 1, sometimes it'll say like this one, quadrant 2, or it could say quadrant 3 or quadrant 4. So the only thing that we're going to have to be careful about that's different is the sign. We have to look at the sign of the ratio. It could be negative. So we'll talk about that in a minute after we've solved it. So we're going to start exactly the same. We're going to draw our right triangle. Call this A, B, C. And now you also notice in this one there happens to be a negative there. We're just going to ignore that for right now. It's not really important. As far as labeling our triangle, it's not important. But the reason why it's there is because it says it's in quadrant 2, and the cosine is negative in quadrant 2. So that's why it is negative. But again, it's not going to affect how we set up our problem. So we're just going to ignore it for right now, but that's the reason it's there. So the cosine is adjacent over hypotenuse. Lost some of our stuff there, but cosine is adjacent. So adjacent of A would be here, 4. Hypotenuse is 11. So we need to find this missing side over here. Let's call that A. So we have A squared plus 4 squared equals 11 squared. We get A squared plus 16 equals 121. So we'll go ahead and subtract. A squared is 105. We'll then take the square root of that. And that's just going to be, well, A equals square root of 105. All right. I don't think there's anything that would simplify that one, so we'll leave it as is for right now. And let's go ahead and write it on there. Square root of 105. So now let's see what we're asked to find. We're asked to find the tangent of A. Tangent is opposite over adjacent. So tan A, opposite of A would be square root of 105. And adjacent of A would be 4. All right, now, last thing we have to consider is this new thing, which is the quadrant. It says quadrant 2. So what we want to do is take a peek at our unit circle and see if the tangent is positive or negative in quadrant 2 here. You might not have all this written out, so what I'm actually going to do is just go through and tell you which ones are positive and negative in each quadrant. So in the first quadrant, the positives, well, x is positive, so cosine and sine, y is positive as well, which also means if the cosine is positive and the sine is positive, that means the tangent is positive. And if the cosine is positive, the inverse of that, which is secant, is positive. If sine is positive, that means cosecant is positive. And if tangent positive, that means cotangent is positive. So everything is positive in quadrant 1. That's why in the first set of problems, we didn't have to worry about a sign because everything was positive. Now in quadrant 2, we do have some negative stuff going on here. Let's start with the positives though. The y coordinates are positive, so that means the sine, and along with the sine, that means the cosecant is positive because it's 1 over the sine. Okay. The x's are negative, which means, so x's cosine is negative, which means the secant is negative. The tangent would also be negative because it's going to be the y over the x, so a negative and a positive, which would make it overall negative. So tangent is negative, and cotangent would be negative. And quadrant 3, positives, well, the x's are negatives and the y's are negatives. However, if the x and the y are both negative, it'd be a negative over a negative when you do tangent, so that would make the tangent positive, which means the cotangent is also positive. However, negatives, we've got the cosine, which means the secant is, and the sine, which means the cosecant is. So everything else is negative. And in the fourth quadrant, we've got the x's as positive, so that means the cosine and also the secant. And negatives, well, y is negative, so that means the sine and the cosecant. And if one is negative, the other is positive, that means, well, the tangent is negative and the cotangent is negative. So these are going to be the signs that we'll use in doing this next set of problems. If you've written these out, then all you're going to have to do is look at the quadrant and determine if that given ratio is positive or negative. So we were asked to find tangent, and this was second quadrant. So we just look at our little sheet here. Tangent in the second quadrant is negative. So we want to throw a negative on with our answer. Negative square root of 105 divided by 4. All right, it probably seems like a lot of work. I know there's a lot of things to check, but just take your time, work through each step. We'll do 2 more here. This is another quadrant 1, so I'm going to not do this one, skip to a different one. All right. New problem. Quadrant 4. Okay, let's go with that one. So as always, we're going to start by drawing a triangle. A, B, C. We're given the tangent, and again, we can ignore this negative sign. The reason why it is negative is because tangent is negative in the quadrant 4. So that's why it's there, but for purposes of labeling our triangle, we don't need to care about that. So tangent is opposite, so opposite of A is 12 over adjacent, which is 35. So we got those labeled. We can go ahead and find our missing side, which is going to be the C in this case. So we've got 35 squared plus 12 squared equals C squared. I'm going to have to bust out the calculator for this one. 35 squared plus 12 squared is going to give us 1369 equals C squared. And the square root of that is 37. That works out nicely. So C is 37. All right, now we're asked to find the sine of A. So let's go ahead and do that. Sine is the opposite over hypotenuse. So opposite of A is 12, and hypotenuse is 37. Let's think about if we can reduce it. Well, we can't because 37 is a prime number. So the last thing we need to consider is the sine. We are in quadrant 4. So we look at quadrant 4 and see if sine is positive or negative. Quadrant 4, sine is negative here. So we want to put a negative in when we type it in. Negative 12 over 37. Let's finish up with one more for good measure. Let's do another different quadrant. So if it's in quadrant 1, everything's positive, which half of these are going to be quadrant 1s probably. So it's positive. You don't have to even do anything different than we did our first set. All right, let's finish with this one. It's a quadrant 2. It's erased. As always, start by drawing a triangle. ABC. Gives us the tangent. You can ignore that negative for right now. Tangent is opposite, which is 16. Adjacent is 63. So we're going to do 63 squared plus 16 squared equals c squared. Calculator for this one again. 63 squared plus 16 squared gives us 4225 equals c squared. So square root that to get c. All right, second square root of that is 65. That's good. So we can now find the sine. Sine of A. Opposite of A is 16. Hypotenuse is 65. And I don't think you can reduce that one either. We just need to double check the quadrant. Quadrant 2, figure out what sine is in quadrant 2. Quadrant 2, sine is positive. So just go ahead and type it in, 16 over 65. All right, that does it. Good luck on this. Do reach out to me if you have questions, if you want to meet up and get some extra help on this or anything else. Let me know. Thanks.